Welcome back. We're continuing to look at graphing rational functions. In this video, we're going to look at our first example of a full problem. I have kind of a checklist of things I want to make sure I get done. These don't need to be completed in this exact order, and in fact, depending on the problem, we'll do them in different orders at different times. But these are kind of the things that before we decide we are done with a problem, we want to make sure we've done. We want to fully factor, and that one really should come as your first step. Fully factoring and finding your initial domain restrictions, just to make sure that we have all of our domain restrictions covered. You want to make sure you simplify by canceling factors. That's going to help you find any holes you might have. Then you want to use synthetic or long division if the degree of the numerator is not smaller than the degree of the denominator. Then you want to identify any holes and vertical asymptotes. Then identify any horizontal and slant asymptotes. Find your x and y intercepts. Point plot using at least 3 points per region. That's a minimum of 3 points per region. Many times you'll actually need more than 3 points to truly understand what's happening in a region of the graph. So you want to make sure that you get at least 3 points per region. And then you're just going to go ahead and graph the curve using the points. So here's my first example we're going to look at. Y is equal to x squared minus 4x minus 5 over x plus 1. The first thing we want to do here is fully factor. I want to make sure that I know all of my domain restrictions. The denominator is fully factored, so I'm going to go ahead and write down my domain restriction that x cannot be equal to -1. I know that domain restriction for sure. So I'm going to go ahead and fully factor the numerator, which factors to be x minus 5 times x plus 1 over x plus 1. So I have fully factored this. I have found my domain restriction. So I'm going to go ahead and simplify by canceling out any common factors. So I see that there is an x plus 1 in the numerator and the denominator. So this simplifies down to be x minus 5. So thinking back to when we were looking at holes, any factor that cancels out, if a factor cancels out after division or after a simplification, it's going to be a hole. So the domain restriction of x is equal to -1 cancels out, so there will be a hole at x is equal to -1, and I actually want to find that ordered pair. I'm going to find that ordered pair by substituting this value of x into my simplified equation. So y is equal to -1 minus 5, which is -6. So I have a hole at the point -1, -6. It's really important that we plug into our simplified equation, not our original equation. If we plug into our original equation, we will get undefined, and that's not really helpful information. So there is a hole at the point -1, -6. In my simplified equation, there are no domain restrictions, so there are no vertical asymptotes in this graph. And actually, if I look at my simplified equation, it's just x minus 5. It's just a line. So there are actually no horizontal and no slant asymptotes, because when I've simplified down, it's not a rational function anymore. This is just the graph of a line with a point missing from it. So I can find my x-intercept. My x-intercept is going to occur when y is equal to 0. So my x-intercept, and actually this is a line in slope-intercept form. So my x-intercept 0 is equal to x minus 5. X is equal to 5. So I have the point 5, 0 on my graph. And my y-intercept, this is just a line in slope-intercept form, so this is going to be 0, -5. So I now know 2 points on my graph. I know the point 5, 0, 1, 2, 3, 4, 5, 0. and I know the point 0, 1, 2, 3, 4, 5, -5. And I also know that I have a hole at -1, -6. Because this is a line, that's 3 points on my line. So I have -1, -6. I'm going to put a hole, a symbol next to that so that I remember that this is a hole, or I'm going to write the word hole so that I remember not to graph that as a solid circle. I know the point 0, -5, and I know the point 5, 0. If I wanted to just throw in another point, like let's say I plug in 2, that's going to give me a y value of -3. So I have the point 2, -3 on there as well. So I'm going to go ahead and graph this. It's just a line with a slope of +1, a y-intercept of 0, -5, an x-intercept of 5, 0, and a hole at the point -1, -6. It's a good idea and good practice to get in the habit of labeling key points on your graph. Key points being the coordinates of any hole along with your x and y intercepts. So this is our first example. I'm just going to step through and check to make sure I've got everything. I know all my domain restrictions. I simplified, did not need to use synthetic or long division. I know my holes, vertical asymptotes. There are no slant or horizontal asymptotes. Found my x and y intercepts. I have at least 3 points because I just really have one region, and then I graphed my curve.